1.2 covers the operation of exponents. We have actually used exponents when we were looking at order of operations, and we might need to back up now and actually define what operation this is and how it works. So we're going to take a to be a real number, a variable, or a quantity. So for instance, a could be equal to just some real number, something like 5. Or a could be a variable. It could be the variable, let's use y this time. Or it could be a quantity. This is what I mean by a quantity, something in parentheses, like a combination of numbers and variables. All right, so 5 would be an example of a number, a real number. Y is an example of a variable, and a quantity is something that is in parentheses that is considered just one unit. That those parentheses kind of make it into one package, one unit. And we'll take n, lowercase n, to be a natural number, which means that it is going to be a positive integer. So it's not negative, it's not 0. N is considered to be positive, so greater than 0. With those two things, we can now define this operation of exponents. A to the n is equal to a times itself n times. So here we've got a times a times a times a. That dot, 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 these 3 dots means it keeps being multiplied until there are n of those a's multiplied together. We have names for the a, the real number, variable, or quantity, that we call that a base, and we then call n, we call that the exponent. Let's look at some examples where we apply the definition to, first of all, a real number of 5. So if we have base of 5 and we've got exponent of 3, that means we are going to take 5 and multiply it by itself 3 times. So 5 times 5 times 5. So there are 3 5s. And we can evaluate that. Of course, 5 times 5 is 25 times 5, and 25 times 5 is 125. All right, 5 to the third, or 5 to the power of 3, is 125. Now, a variable y with an exponent of 7, we're going to take that variable of y and multiply it by itself 7 times. So y times y times y times y times y. And I've lost track of how many times I've said y, but there are 7 y's there. If we simplify that, that's just going to end up being y to the 7th again. So if we have a variable, we are just writing it with its exponent, but know that that's what it means. It's taking that variable multiplied by itself, whatever the exponent is. Now we have a quantity 3xy, and that entire quantity is squared. We know that that squaring, or that exponent of 2, applies to the entire quantity because of those parentheses. So we just apply the definition where we're going to take that quantity 3xy and multiply it by itself, and there are 2 of those because the exponent is 2. Now we're going to look at some rules of exponents, and there are 6 of these total, and we're going to go one by one, look at some examples, and then we'll do examples in the practice problems where we combine these rules. So the first one is the product rule. So because of the name, that word product, that implies that we are going to encounter some multiplying. We get a product when we multiply 2 things together. So for any base a and exponents m and n, so this time we got 2 exponents, but you can see that we have a times a. So we're multiplying this base of a. And the base of a has 2 different exponents, m and n. And when we multiply, or when we have a product of the same base, we add the exponents. So a to the m times a to the n is equal to a, the base showing up one single time, a to the m plus n. So let's look at some examples. 2 to the 4th times 2 to the 3rd. The base that we have in common in both of those things is 2. So we're going to have that be equal to that base of 2, that doesn't change, and we add the exponents. So 4 plus 3, so we can write that as 2 to the 7th. Now we can evaluate that. That's 2 times itself 7 times. Which is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. Okay, let's look at this next example. X to the 5th times x to the negative 2. So here we've got an exponent that has a negative in front of it. Well, the product rule will apply. We have the same base of x, and we add those exponents. So 5 plus a negative 2, so that's 5 minus 2. So that ends up being x to the 3rd. Now let's look at this last example. We have 2x minus 1 is our base for here, but if we look at what we're multiplying by, it is not the same base. So the product rule is not going to apply. We cannot combine those exponents because we have 2x minus 1 as one base and 2x plus 1 as another base. But what if we had the same base? So let's rewrite this. 2x minus 1 squared times 2x minus 1 cubed, or to the 3rd. Now, because we have the same base, the same thing inside those parentheses, we're going to be able to apply the product rule. So 2x minus 1, that entire quantity, adding those exponents, 2 plus 3, so 2x minus 1 to the 5th. The next rule is the quotient rule of exponents. That word quotient implies that we are going to have division. And remember that division can be represented as a fraction, like we have in this definition, and also in using the symbol, the dividing symbol. So the quotient rule says that for any base a and exponents m and n, if we are dividing that base with one exponent by that same base with another exponent, we can write it as one base and take the difference in the exponents. So let's look at some examples. All right, we've got 4 to the 8th divided by 4 to the 5th, and we've got that common base of 4, so we can write that 4, and because we're dividing, we subtract the exponents, and subtraction, the order matters. We want to subtract 5 from 8. 8 minus 5, we're going to get 4 to the 3rd. We can actually evaluate that. That's 4 times itself 3 times. 4 times 4 is 16. 16 times 4 is 64. X to the 5th divided by x to the negative 2. So remember that fraction line is the same as dividing. We have the same base top and bottom, and we're just going to subtract, even though we've got that negative exponent in the bottom. So 5 minus the exponent of negative 2. So a little refresher on subtracting negatives. If we subtract negatives, subtracting a negative makes it a positive. So that ends up being 5 plus 2. So we end up with x to the 7th. Now this next one, actually we're going to combine our product rule and our quotient rule. Let's take care of the numerator first. So we'll assume that it has parentheses around it in the numerator, which by order of operations tells us to do that part first. We've got base of y and exponents 2 and 3, so we can add those together. And then that's all over y to the 4th. We haven't done anything with that yet. So we get y to the 5th over y to the 4th. Now we can apply the quotient rule, and we can write that y one time, subtract 5 minus 4. Turns out it is just y to the 1. Well, y to the 1 is just y. So anytime we have an exponent of 1, it's just having that base all by itself. Now we have the power rule of exponents. That word power is going to imply that we are taking an exponent to an exponent. There's going to be 2 exponents applied to one single base. when we apply the power rule. And it says that for any base A, and again, two exponents, m and m, if we have that base A, it's applied to one exponent m, and then that entire quantity has an exponent of n, we can rewrite that without parentheses if we multiply the exponents. So when we have an exponent raised to a power or an exponent with an exponent, we can multiply those exponents. Let's look at some examples. We've got 3 squared, that whole quantity to the 4th. This is our power rule. We're going to take that base of 3, and we've got an exponent to an exponent, so we multiply the 2 and the 4. We get 3 to the 8th. We can evaluate that. This might be time to pull out the calculator. So plugging in 3 to the 8th, we get 6,561. Second example, we've got y by itself times y to the 3rd to the 5th. The y that is out in front, it does not have an exponent applied to it at all. So we are not going to apply any of our rules to this exponent or this y that is out in front. So that's just going to stay y. But we do have this other y that has an exponent to an exponent. So we're going to multiply those exponents together. So 3 times 5. And the y is out in front. We multiply 3 times 5, and that's 15. So we have y times y to the 15th. Here we can apply our product rule, which says when we have the same base multiplied by itself, we add the exponent. So now this first y, it doesn't have an exponent, but we want to remember that it has an exponent of 1. If we don't write the exponent, that implies the exponent is 1. We're going to have y to the 1 plus 15, so y to the 16th. Let's look at number 3 here. So in parentheses, 6 to the 4th divided by 6 squared, and then that whole quantity has an exponent of 3. We're going to take care of what is in the inside first. So we've got division. We're going to use the quotient rule. We're going to take that 6 of the base. Because it's division, we subtract the exponents. And then that whole thing has the exponent of 3. So we end up with 6, 4 minus 2 gives us an exponent of 2, and then that whole thing has an exponent of 3. We've got an exponent with an exponent. The power rule tells us to multiply. We get 6 to the 6th. And using the calculator to evaluate that, we get 46,656. The next rule is negative rule of exponents. This will tell us what to do if we end up with an exponent that is negative. Again, we're starting with a base of a, exponent of n. If we have our base of a and the exponent is negative, we generally want to write only positive exponents. So to make it positive, we have to take the reciprocal of the base. So to take the reciprocal is basically to move the base from numerator to denominator, or we'll see if it's already in a denominator, we move it to a numerator. Let's jump into some examples. Number 1 here, we've got 7 to the 4th to the negative 2. First, apply our power rule where we can multiply those exponents because we have an exponent to an exponent. We get 7 to the negative 8. Okay, here's where we apply the negative rule. We have a negative exponent. We take our base and we're going to take the reciprocal. So that means we take 1 over 7. We take that 7, which is in the numerator, 7 over 1, and we put it in the denominator. That, seemingly by magic, will now make that exponent to be positive. So we get 1 over 7 with the exponent positive 8. We're just going to leave it like that rather than evaluating it using the calculator. Let's look at the next example. We've got x to the negative 5 times x squared. First, we can use the product rule. We've got the same base of x. We can add the exponents, negative 5 plus 2, so we get x equals negative 3. using the negative rule of exponents, the reciprocal of x, so that's 1 over x, and then it has a exponent of positive 3. Here we've got a base of y minus x. So the base is this entire quantity, y minus x, and we are multiplying those so we can add those exponents. We're going to have that quantity y minus x, adding the exponents, 4 plus a negative 6, which is 4 minus 6. That results in the quantity y minus x to the negative 2. Now applying our rule of negative exponents, we're going to take the reciprocal of the base, which is y minus x. So that becomes 1 over y minus x, and then the exponent becomes positive. So we end up with 1 over y minus x, that whole thing squared. Last example, let's say we've got 1 over x to the negative 4. A negative exponent is in the denominator. We're going to apply the same rule. We're going to take the reciprocal. Since the base x is in the denominator, taking the reciprocal puts it in the numerator. So we can think of just flipping that 1 over x and flipping it to be x over 1. And that is going to then make the exponent positive. 1 over x to the negative 4. If we take the reciprocal, we just get x, and it gives us a positive exponent of 4. Okay, here, this is my favorite rule of exponents, the zero exponent rule. For any non-zero base of a, if we have exponent of 0, it results in 1 every single time. Let's look at the examples. Number 1, we've got the base of 55, and it has an exponent of 0. That is going to be equal to 1. Next one, quantity 3xyz squared. Well, that entire quantity in parentheses has an exponent of 0, so that is equal to 1. It doesn't matter how fancy that thing is inside the parentheses, that quantity. If that whole thing has an exponent of 0, it results in 1. Now let's look at the next one. We have 4 squared x cubed times y to the 0. The only piece that has 0 as an exponent is the y. So y to the 0, that equals 1. But notice that we have 4 squared. Well, that does not have an exponent of 0 on it. So 4 squared, we can evaluate that, that's 16. And the x cubed, the x to the 3rd power, the x with the exponent of 3, that stays as x to the 3rd. And then that's times a 1 from the y to the 0, but we don't really need to include that. So it's just 16x cubed. The next rule that we're going to look at is the power of a product rule of exponents. That means that we have got a product that it has a power applied to it. So inside parentheses, we've got 2 things multiplied together, or we could have more than 2 things multiplied together. It has an exponent on the entire thing, the entire product. So what we do is we distribute that power, that exponent, to the things in the inside. So it becomes a to the n times b to the n. Let's look at an example. We have 5x squared. So we are going to take that exponent of 2 and apply it to the 5 and apply it to the x. So we get 5 squared times x squared. And simplifying 5 squared, we get 25, and then x squared. So 25x squared. Let's look at the next one. We've got 3 things multiplied together, 3x to the 4th and y. We're going to take that exponent that's on the outside and apply it to the 3, apply it to the x to the 4th, and apply it to the y. So 3 with an exponent of 3, x to the 4th with an exponent of 3, and y to an exponent of 3. 3 cubed is 3 times 3, which is 9 times 3, we get 27. And then we can apply our power rule here. We have x to the 4th to the 3rd, so we multiply 4 and 3 and get 12, and then y to the 3rd. All right, example number 3. We can apply that exponent of 4 on the outside to the 2, to the x to the negative 2, and to the y squared. So 2 to the 4th, x to the negative 2. Notice I put that in parentheses and then apply that exponent of 4 to that whole thing. Same thing here with the y squared. I'm going to say that y squared, that whole thing has this exponent of 4. Okay, not quite done. 2 to the 4th, we can evaluate that. 2 times 2 is 4, times 2 is 8, times 2 is 16. And we've got an exponent to an exponent on the x, so negative 2 times 4, that's going to give us x to the negative 8. And y squared to the 4th, we can multiply the 2 and the 4 and we get y to the 8th. Now we are still not done because we want to write this without negative exponent. 16 and y to the 8th are, they have positive exponents, so we can just keep those in the numerator. But remember, that negative exponent puts that base into the denominator. So that base of x goes down here in the denominator, and the exponent becomes a positive 8. So we get 16y to the 8th over x to the 8th. This is our last rule for exponents. Any two bases a and b, if they are in a fraction, a over b, and then has an exponent applied to that entire fraction, this rule says that we can apply that exponent to the numerator and to the denominator. Let's look at some examples. First of all, we've got 6 over y, fraction inside parentheses, and it has an exponent of 2. So we're going to apply that exponent of 2. We're going to apply it to the numerator, so we get 6 squared, and apply it to the denominator, which is y squared. Simplifying 6 squared is 36, so we get 36 over y squared. Let's look at the next one. We're going to bring that 3 as an exponent and apply it to the numerator, so we get x cubed, and apply it to the denominator. Y squared, all right, y already has an exponent, so we want to think of that as in parentheses, but then on the outside of the parentheses, apply that exponent of 3. Numerator is x cubed, x to the 3rd. In the denominator, we've got exponent to exponent, so we can multiply 2 times 3. So our final result is x to the 3rd over y to the 6th. For our last example, we can do this one in a couple of ways. We can first of all recognize that we've got a negative exponent. The negative exponent tells us that we take the reciprocal of what it is on, the base that it's on. So we're going to take the reciprocal of 2x over y, just flip that over, and it becomes y over 2x. And then the exponent is positive 3. Now we apply the power of quotient rule that we just learned. We bring that exponent of 3 onto the numerator, so we get y cubed, and we apply it to the denominator, so we get the quantity 2x cubed. We have a little bit more to do. We can bring that exponent of 3 inside the parentheses and take 2 to the 3rd times x to the 3rd. We can simplify 2 to the 3rd, which is 8. And our final result is y cubed over 8x cubed. Let's look at it a different way, where first of all we use our power of a quotient. So we bring that negative 3 and apply it to the numerator, so 2x to the negative 3, and apply it to the y, so y to the negative 3. We bring that negative 3 on the inside of those parentheses, so we get 2 to the negative 3, x to the negative 3, all over y to the negative 3. Writing this with just positive exponents means that we take each of those bases that has a negative exponent and we're going to move it. So the 2 starts off in the numerator, so it goes in the denominator, and we can change the exponent to positive. The x starts out in the numerator. We move it to the denominator, change the exponent to positive 3. Y starts out in the denominator, it goes in the numerator, and we change the exponent to a positive 3. So finally, simplifying the 2 cubed to 8, we end up with the same result that we did the first time around.